Hi, this is Bharat Burgojo. Today I'm going to explain the assignment 6 for the solution. So optimization and statistic grading descent. So I will tell my understanding in my own words. So what the code exactly I have learned and what I understood. So here the statistic SGD stands for statistic gradient and descent. It's an efficient optimization algorithm for the minimizing the cost of function and optimization problems. So here we use small subset of training examples for in this functions. We use the grade of the cost. So and we also contrast to the tradition of gradient descent. So it's true gradient. So we all use training examples in this assignment. So here first we gonna create the linear model on weight height dataset using LGD. So after importing the necessary packages, which was matplotlib library and the plotting functions which was in library. So and we're gonna import all these packages of from the library, and we're gonna generate the data. So here we gonna import the random and numpy as np. So importing and matplot library as a plotting function, we gonna plot as a graph, so we can use plotting. So and we import the training set and test set to, and from the sklearn model selection. So here we have taken the 42 as a seed, so we're gonna put it as a random function. So we have taken it as a random. So and as we have assigned for the numpy values and for the seed. So after this one we gonna generate data, and we're gonna involve the weight and the input features. So we have taken the to generate the 50 random weights from starting 50 to 120. We're gonna sort them off, and to sort them off we have taken a random integers values of 40, 20 and 100. So we're gonna assign it to x. So and for the y we have taken height and the target values. For this we have taken also a random values. So we have taken here an array. So the item is divided into 30. So and we have adding the random integer values 2 3 1, and the random rand function for the item in x. So what are we getting in the x, we gonna add this. For the array is we gonna assign it as y. So after writing the function of the plot, so the data with the option, we gonna plot them in future. So we're going to define the data for the plotting line function. So we have taken the x and y, and the model name we have an assign as none. So for the figure we gonna take the size is 8 to 8 comma 6. The size is a 8 to 6 ratio. So here we have changed the dot per inch, as we have taken 100, before we have taken 80. So we're gonna plot the function. So uh, so if the model is not none, we gonna predict some values. We have assigned m for a model, and which will be multiplied into x, and we gonna uh, add with the model c. So after we prediction the values of x we got, and the predictions we done. Here we're gonna plot the figure. So we're gonna label x value as weight into kgs, and the font size is 16. So for the label y we're gonna take height. So here here the height, we have taken the height for y, and the font size is also 16 here. And we're gonna name it, we're gonna name the visualization, sorry, we're gonna name the graph. The title we will be given for the graph will be data visualization. So to use this function we're gonna write a small code. We're gonna assign a plot underscore data of line of x into y. So after plotting we have got these dotted lines, this plus symbols. So this is the weight we got, and we have assigned this is the height we have, and this is the weight we write. So here we have taken 40, 50, 60 to 120, and we have taken the 3.5 to 6.5. So we got these plotted lines. So after getting the graph, so we're gonna split the data into training set and test sets. So there will be X train set and X test set, and Y test and train. So we're gonna split the data into X and Y, as we have taken the test size will be 0.1 and the random state will be 42. So here after that we're gonna take the linear model, has two parameters, M and C, which we have taken before, as and this will be expressed by y is equal to mx plus c. So here we use some mathematical functions, is a regression problem. So where y is a dependent variable, v of weight x, and x will be an independent variable of height. So here we use a regression problem. So we use regression problem to reduce the loss function, which we use a mean squared error. To reduce this one, we use regression function. So we know we got regression MSE formula here. So where the n is the number of samples and yi is a true label of I value, and yi bar is the predictor value which we are predicting. So here so here we have written a code. Yeah. So here we have written a code for the MSC. Uh, so we have written a loss function. We have got a prediction and target values. We have written error and square error. So the mean squared error also we have assigned all these values, and we the value will be written, which will be mean squared error. So after predicting the values, this yi is equal to mxi plus c, where xi is a features vector of ith sample. So we have update the parameters and bias. So we got some mathematical calculations here. So, and where these will be a gradient which is given by, so we got a c and n. So n is a batch size. So we have updated the rule of weight and bias given here. So here n is a learning rate. For the exercise 2, we gonna define a single step statistic gradient descent. So every iteration step, it updates a parameters values. So the statistic gradient descent we gonna put as x, y, m, c, all we have taken before. Here we also taking a batch size. So here we select a random batch from the data, and all data points have a uniform probability of getting a sample. So here the num will be assigned as 0, x shape of 0, and the v will be assigned as a size as batch size. So x batch will be a num value of squeeze x indicates, and is same as y, which we gonna predict the y values of x batch dot m plus c. So here we are assigning an y prediction value and y batch data into an error. So we gonna remember the calculation of the gradient of the loss, we which we have with respect to the parameters. So we calculate the gradient here for the m and c. For this, we gonna, for the every parameters, it gonna update the weight and bias. For all these things, we gonna assign the m and c values to the m and c new. So we gonna retain the values after updating. So after starting a random initial models, we're gonna saving the model parameters from the dictionary so that we can use for this future use. here the model C and a model C was assigned for the model. So the model parameters will be printed, and we gonna, after printing the model parameters, we getting two values of the M and C, where we getting M value is 0.73 as a decimal number sum, and the C value will be 0.209 as a decimal number. So after getting these parameters, we're gonna plot X and Y model. So after plotting the height and weight, we have done, we got a maximum line for this one, from the starting to high. There's a curve. So and down we also seen here some dotted points, these are hyperparameters. So there will be three hyperparameters. uh, we have to try them. So learning rate will be 0.0001. So batch size we have taken 16, and number of iterations we are taking 10. So for the M, we're gonna assign as a model for the M. We're gonna assign C as a model C. So we have not mentioned for the losses. So here we are using a loop function in the range of number of iterations as a MC statistic gradient of X train and Y train and MC and learning batch tracer. We have doing a normal generalization performance on the test set. So we are taking a predictions loss, and we are printing these values. We are getting the how much losses we are getting. We gonna show got the output. So we are getting at 10 iterations, the loss will be reduced from 301 to 229. So this is an output we got. How the losses will be reduced, taking the iterations. When iterations are increasing, the loss will be decreasing. So after writing this plotting function using the plot function and tag, we are tagging the none for this. And we have taken X label, Y label, and we are assigning the title as loss curve during training. So we're gonna plot this loss function. We are reducing the number of iterations, as this is reduced from 302 to 229, as this is an output for the learning rate we have taken. And this is a good model we have taken. So the new model will be assigned as a M and C, which we have taken in a ratio. So after plotting the data in an organized manner, so we got the an arrow. Before we have seen the dotted lines we here, but we, after plotting it in an organized manner, we have got this the new model of the data dotted line. So this is my understanding. So thank you.